Acetone is commonly used as a paint thinner, a paint cleaner, or a solvent and can be found in many hardware stores. In a laboratory setting, acetone is used as a solvent for liquid-liquid separation and many other solvent extraction techniques. This video primarily serves as a testament to being safe with acetone and the dangers that can arise with using it. Acetone is a ketone with a carbonyl group and is commonly known as acetone dimethylketone or 2-propanone. One of the main contributors to acetone's high volatility and flammability is its low boiling point and very low vapor pressure in comparison to other solvents. When exposed to an open flame or its autoignition temperature, acetone undergoes a simple decomposition reaction, releasing carbon dioxide and water. It also releases energy in the form as what we call fire. The reason why acetone and many other organic solvents even combust in the first place lies in the concept of bond energies. However, it is too detailed for this video and it can be delved into at a later time. But basically, all you need to know is that when carbon dioxide is formed in a combustion reaction, two double bonds form between the carbon and oxygens on each side, which are very strong bonds and release a lot of energy. This energy is seen to us as fire, or the flammability aspect of many organic solvents. By looking to acetone's polarity in comparison with water, we can see that acetone's dipole moments are very similar to water's. However, if you look closer in water's structure, we can see that it has a strong hydrogen bond between oxygen and hydrogen. Acetone, however, does not have these strong hydrogen bonds and instead only has dipole-dipole forces and London dispersion forces, which are a lot weaker than water's hydrogen bonds. This simple property of water causes it to have a higher force of adhesion, which is a property that describes a substance's ability to stick to other things. Water can stick to glass and doesn't spread out as easily as acetone because acetone is a lot less polar than water and sticks a lot less to things. This causes acetone to spread out a lot more, and as well as letting off its volatile organic vapors, it can reach sources of combustion and easily ignite or explode. This is one of the reasons why acetone is so dangerous. For this reason, acetone should be dealt with very carefully and only in a properly equipped lab with a fume hood to prevent organic fumes from combusting. If you don't have a fume hood, it is generally advisable to use acetone outside as vapors can travel to ignition sources and explode or ignite. I filmed this video outside in a highly controlled environment to prevent any acetone fumes from traveling in enclosed spaces and possibly igniting. However, I do have a fire extinguisher in the background just in case things get out of hand. When dealt with properly, acetone shouldn't cause you any problems, but when dealt with very sloppily, acetone can be extremely dangerous to you and the people around you. In this video, I'll be demonstrating some scenarios which may cause or pose a threat to you or others. For this first demonstration, I suck up a random amount of acetone and prepare it for the next demonstration where I show acetone being handled improperly. An ignition source is held to the right of the dish while I squirt the acetone to show the effects of acetone flames traveling to the secretion source. You can see the acetone quickly travels up to the syringe and the syringe is ignited. The volatile flame quickly spreads around the dish, which could be a huge problem if you're conducting experiments with acetone indoors, lighting things on fire, and potentially your entire house. I do this again with a lot less acetone and I squirt it further away. You can see how quickly the flame travels to the source of secretion, which is the syringe. You don't really see it here, but the syringe actually catches on fire and I had to dispose of it after this video. In this next demonstration, I pour a bunch of acetone from the beaker into the dish. You can see that the acetone almost explodes, immediately igniting and spreading the flame around the entire dish. I tried blowing out the flame, but for a while it only made it spread around even more and potentially made it worse. It eventually did go out though, but it could be a lot worse in a bigger situation. Once again, I prepare another demonstration where I pour a tiny amount of acetone further away from the ignition source, and you can see how quickly the acetone ignites as the vapor begins to travel towards the source of ignition and ignite the entire puddle. It's honestly kind of hard to see here, but the acetone puddle didn't even travel to the flame, and it was the vapor itself that ignited the puddle. After the acetone in the beaker was completely depleted, I did another demonstration where I showed that residual acetone vapors can still be flammable and potentially explosive. The acetone in the beaker burns for quite a while. In this last demonstration, I pantomimed someone who's sloppily pouring acetone into a beaker, spilling it around the sides, and potentially causing an explosion and fire risk. This time, though, before igniting the lighter, I made sure the acetone was capped to prevent any catastrophes. It's also kind of hard to see here, but you can see how quickly the vapor travels towards the ignition source and lights up the entire beaker. I further pantomimed this idiot by moving the beaker across the dish and pretending to spill it over as an idiot would do. It's important to note, though, that this was a controlled spill, and in an actual accident, the beaker would likely become no less than a Molotov cocktail and spread fire everywhere, potentially burning down your entire house or apartment complex. Thank you guys for watching, and I hope you enjoyed this video. Please leave a like, a comment, and subscribe if you can.